Thanks everybody for being here. My name is Ethan Landefeld. I'm the Senior Product Manager at Plus One Robotics for Parcel Induction. And today, the topic is basically our journey through Parcel Induction through the years. So it's going to be about 10 years of history in 10 minutes. All right, so just to get started, a little bit about myself. And some of my background. I tell people that my career, you can kind of divide into two big segments. The first of which was my life as an engineer. So I studied at Texas A&M University in College Station, mechanical engineering. After that, I went into the oil and gas industry where we designed very advanced drilling tools. So to actually drill for oil up to 5 miles beneath the surface, really high vibrations, temperatures, pressures, super interesting from an engineering perspective. And that's one of the last tools that I designed as an engineer. And then I decided to join the dark side, left engineering. I studied my master's in innovation management at the Technical University of Berlin and the Warsaw School of Economics in Poland. And then I made the pivot into product management. So I studied innovation management, now in product management. My first job out of that was actually in the HVAC industry. So getting used to the whole trade show circuit. And then that picture kind of in the middle bottom is my son Tony and I. So this is actually after we received the first of the Induct 1 machines into San Antonio, brought the family in on a Saturday, and we applied the logos to the canopy. So a nice family Sunday fun day. Okay, so I recognize that some of you may not know what induction is. I certainly did not when I started at Plus One 4 years ago. So I think we need to start off with, all right, what is induction? And as we would do before ChatGPT, I went to Wikipedia and tried to find out what induction is, all right? So, the top definition, production of an electromotive force across an electrical conductor in a changing magnetic field. So if you think, if this matches your expectation of this presentation, you should probably leave now. It has nothing to do with that. All right, so the definition we're really looking for, actually borrowed from our good friends over at Cognex, kind of paraphrase, but when we talk about induction, this is actually the singulation and introduction of parcels or other items into a sorting system so that they can be routed to their correct destination. So that's what we're talking about. We're not talking about electromotive force. Before we get started with basically Plus One's journey in robotic parcel induction, I think it's helpful for us to take a moment and realize that even though we are surrounded by all of this cool technology, automation, robotics, we have to really take a step back and kind of get out of our echo chamber and take our horse blinders off and realize the status quo is still very much manual induction. And so taking a look into a hopefully not so typical manual induction operation, obviously not a pleasant job. Definitely not climate controlled, given the 50-50 ratio of shirtless to shirted employees. But I can assure you that, even though this may be an extreme example, it is still not a very pleasant job. Companies really struggle to keep people in this type of work. It's very repetitive. It's kind of mind-numbing at times. So it's something that the industry's been looking to automate for a very long time, which gets us started on the journey that Plus One has taken. And so we'll start off with phase one, call this the proof of concept phase, from 2014 to 2019, roughly. And so this all kind of started with a major e-commerce company that came to Southwest Research Institute, and actually I had some conversations with my boss, Sean Edwards, now CTO of Plus One Robotics. And the question was, all right, how can we automate this process? The solution ended up being with machine vision and robotic arms. But as you can see in that time, the parcel mixes were very easy, all right? So very nice boxes, very nice envelopes. If anybody here has been into a distribution center recently, that's not realistic. That's not what things look like. But it was proof of concept, right? So at that time, we actually survived with just using 3D vision. So we actually did not need AI for our vision software. And you can also see that the gripper design was very simple, just based on this package mix, right? Just want to see if we have any competitors in the audience. This is a great time if you want to zoom in and take a photo of this gripper. take it home, replicate it. That would be very nice. There's a reason that our grippers do not look like this anymore. All right. But it was a different time, and it was good for the package mix that we were handling. And then finally, in that time, every new robot cell that we made was actually a custom design. So there was no replicable content. It was like very much project-based instead of product work. Moving on to phase 2, when we first started to have our first operational successes with this technology, so roughly between 2020 to 2022. And in this time frame, this is actually when our customer shifted from innovation teams to operations teams. And so these are both very important stakeholders in the introduction and deployment of advanced technologies, but they have very different KPIs and very different motivations. So on the innovation side, they're partially judged at least on the number of new technologies that are introduced into the distribution centers in their network. But on the operation side, they may appreciate innovation, but they're measured on output, right? So throughput, quality, things like cost per piece, and whatever it takes to get that job done, whatever the best solution is, whether that's automated or not, is not nearly as important to that team as it is to the innovation teams. So that was a kind of a change, shift that we had to make internally in how we thought about things to realize, hey, these operations teams are depending on this technology. It better deliver, it better be better than what the status quo was. And so we'll start off with the first video. Let's see if this works. Okay, so this is actually the design of an induction cell that has gone into production for DHL. This video is from our factory, but we have deployed the system. It has run through multiple peak seasons, so very intense demand for the system. Lots of poly bags, lots of padded mailers, envelopes, things that have been damaged on their way from one facility to the next. And so this is really kind of where we cut our teeth, is in these operational successes, and then implementing this into a design. As I mentioned, now we're starting to see poly bags, and so that was actually a big thing that occurred in this time frame. We would have definitely preferred for it not to, but it did help to spur innovation on the software and the hardware side. So on the hardware, we went from having a very simplistic gripper with a single zone to we introduced zoning to have more precise manipulation of the items. And then on the software side, we started to introduce AI, so reinforcement learning, in order to enable detection of these kind of difficult package types. And finally, in this phase, so now we're moving from, all right, very custom designs for every new robot cell to, okay, within one customer, we've got a design, and then we replicate it within that customer. Still, at this point, nothing that was, hey, here's a design that actually works for multiple customers, but it was a step forward for us. And Alex, can you press the next video, please? One other thing that we started to leverage in this time period was the use of simulation. So when we started shifting to operations teams and realizing the very demanding throughput requirements, one thing that helped us a lot in these early discussions was actually the use of simulation. And so you can see here, it's actually very accurate to what happens in real life. So this helped us a lot in the proposal process to be able to tell a customer what to expect even before the design physically existed. So this was all very nice, very good, but the entire process for the customer, from the very first conversation to the deployment, handoff, and training regarding that robot cell, which was a very long process. And so we looked at this and we said, hey, we need to speed this up somehow. So we looked at the whole process, identified the bottlenecks in solutioning, detailed design, fabrication, procurement, assembly. And we said, hey, we need to create kind of a one-size-fits-most product for, let's say, 80% of the market that we don't need to actually redesign every time. Think of it more like a catalog item. I still remember, I don't see Peter here, but in the early days, we had a meeting about this, and he was challenging us. He said, hey, we need a robot cell that's actually more like an appliance. Like, why can our customers not order something as if it's a refrigerator, bring it in, hook it up, the inputs and outputs, and it's done. So it's, granted, not quite that simple as plugging in to an electrical outlet and leaving, but we've made great strides towards that end goal. Also, when we decided to do this standardized product, we actually used one of our more challenging customer applications, which was to try to achieve over 2,000 picks per hour with an induction robot cell on a single induct spur. So we used that and we said, all right, whatever we make, it better not only be for this one installation or this one customer. This thing needs to be universal. So you can see kind of in the bottom center, the original concept, the quote unquote appliance induction cell. And then this is actually the current system reality. So this whole process took about a year to develop the solution and then about another year to fully optimize everything and get it ready for deployment. Throughout this process, we also leveraged our more than 1.5 billion picks to get all of the lessons learned through that process with regards to exception handling and other items to really create something that was, reflective of the fact that we have almost a decade of experience as a company, and even more than that if you count the very early research that was done at Southwest Research Institute. Finally, one thing that was very important with the Induct 1, the standardized cell, is that we are now achieving predictable performance. And so I mentioned earlier that we started using simulation technologies to be able to give the customer an idea of what to expect. Now we actually have 2 of these cells in our facility in San Antonio. We're running parcels all the time, constantly testing the software, constantly making sure that we are not going backwards, that we're always going forwards in terms of performance. And now we know when somebody asks us, what can I expect? We have a very real answer to give them. We test with a variety of parcel sets. And of course, every customer believes that their parcel set is unique, and to some degree it is. So in that case, we are also very easily able to bring in new parcel mixes, dump them into the machine, and get a very accurate read on that specific parcel mix. So that's all great. We did create the standardized assembly, but this is kind of where the rubber meets the road. Does it work in production and does it work for multiple customers, right? That was the whole purpose of this. It's why we took a bet on standardizing the solution. And so the answer is simply yes. So this is, this is a video of one of our first installations actually running through the peak season. We have installed this at multiple customers now. And the solution that I think Alex is about to play now has accumulated over 1.5 million picks in production, many of which were during the peak season. So I had the very unique opportunity to supervise the robots in December last year. Very fun, like standing there and watching all of the Christmas presents coming through and being handled by the robots. So here you see now, this parcel mix looks a lot different than what I showed in the phase 1 slide, right? Now we've got all kinds of poly bags, black, white, boxes. It's basically the highest degree of variability that you can expect. That's what we're dealing with as an input. So with the success, now we're transitioning to scale up. So that would be kind of the phase 5 if I were to give this presentation next year. But I will end with a slide on what's next, at least in my view. So I do believe that while the status quo still very much is manual induction, that is not going to remain the case forever. And I do believe that companies that are kind of sticking with that status quo and limping along, they are forfeiting a potential competitive advantage that they could have by automating. So, right now, automating is a competitive advantage. In the future, it's actually, it's going to be hurtful for companies to not do that. Second point, I believe that we're going to start seeing more purpose-built system components for logistics. So one example of this is the robot arms that we essentially borrow from automotive manufacturing. And they're very much spec'd to automotive manufacturing. So with a very high degree of precision, that's not necessary in logistics. But yeah, so we expect to see more innovation in this area as the volumes of robots grow in logistics. And finally, increased variability of the material to be handled. It is only going to get more variable, not less, as we saw with the transition from the very nice boxes in the beginning to the proliferation of polybags. And just one example, a quick plug. We're now handling apparel induction items in clear polybags. So I don't want to take any thunder from the YouTube channel, but if you want to scan the QR code, give it a watch and a like. There you go. Thank you. Really nice video that we did together with our partners Eurosort on a new apparel induction cell. All right, I'll end with our tagline here. Warehouses can be unpredictable. Throughput doesn't have to be. As I mentioned, we have the Induct 1 standardized solution. We know what to expect. It's in production. It's proven. And yeah, please feel free to scan the QR code at the top right. Connect with me on LinkedIn. Happy to have conversations about my favorite topic, parcel induction, or other topics. And yeah, as always, thank you for the time and look forward to connecting. Thank you.